Okay guys, in this section 10-6, we're going to be looking at polar coordinate conversion. So we're going to be converting back and forth from polar coordinates to rectangular coordinates, and then vice versa from rectangular coordinates to polar coordinates. So in the last section we introduced polar coordinates and showed you how to plot points in polar form and that sort of thing. So like I say, the main purpose for this section is to learn how to convert back and forth between the two. So like for example, if I have a point that is 2 comma pi, right, in polar coordinates, how would I convert that to rectangular? Or if I have like -3 comma 2 in rectangular, how would I convert that to a polar coordinate? So the idea of getting an understanding behind how to do that is to understand the relationships between the components of each one of those types of coordinates, right? So polar coordinates consist of r, the radius, and the angle theta, while rectangular coordinates consist of x and y, right? So to establish the relationship, we let the polar axis coincide with the positive x-axis and the pole of the polar coordinate with the origin of the rectangular coordinate, all right? And so if we take a look at this figure here, you can kind of start to see the relationship between the different types of coordinates. Like for example, the first part of the polar coordinate is the radius. Well, right here, if this is my point, here's my radius, but the x and y are just the legs of the right triangle that's formed by the radius and the x and y coordinates, right? So we all know what the relationship is there. R squared equals to x squared plus y squared. So that's how r is related to the x and y of the rectangular coordinates. But what about the angle theta? Well, when I'm looking at my angle theta now, we should be able to recognize that in this right triangle that the tangent of this angle is equal to y over x, right? And so as we go through and take a look at that, then we can understand how these two are related to the regular rectangular coordinates, right? And then also, as far as if we were just trying to relate it the other way around, then you could take the cosine of the angle and is equal to x over the radius, and then we'll rearrange these two to be able to come up with a conversion sort of chart, right? And so this kind of expresses the relationship between the two. So how do we convert? So if you're going from polar to rectangular, okay, then you're starting with polar, you're trying to get it to rectangular. So if you're starting with polar, you have the r and you have the theta from the coordinate. You plug them in here to the cosine equation, and then that gives you the x. And then that's formed by rearranging this equation, right? And if you want the y coordinate, you plug the r and the theta into the sine equation here, and then that gives you the y, formed by rearranging this equation, right? And so this is how we convert from polar to rectangular. That'll give you your two rectangular coordinates. Now what if we're going in reverse? We want to go rectangular to polar, all right? If we want to go rectangular to polar, then what I can do is I can take tangent of the angle equals to y over x. These are my rectangular coordinates. I can now solve this for theta, and then that would give me my angular component, or the second component in the polar coordinate system, right? And if I wanted the r, the first component, then of course r squared equals to x squared plus y squared, and that's what we saw up here when we were looking at the triangle, right? So this is the key to understanding how the two sets of coordinates are related to each other, and then thus gives us the formulas that allow us to convert back and forth. So let's try some. So let's say I wanted to convert this point 2 comma pi to rectangular coordinates. So remember, 2 comma pi, the radius is 2, the angle is pi, so we can kind of visualize where that point would be as a rectangular coordinate. So now if I wanted to convert from polar back to rectangular, I'll use this set of equations. Well, the x is going to be equal to, the r is 2 cosine of pi is the angle. And so let's see what that is equal to. That's going to be equal to 2 times. So now I need to see what the cosine of pi is. And probably the quickest way in order to do that is to look back at the unit circle. And so cosine of pi, remember cosine is the x coordinate, so the cosine of pi is -1. So I'm going to plug my -1 in right here and multiply that out, and that will give me -2. So -2 is the x coordinate. The y coordinate, we'll use this equation, and it'll be y equals 2 sine pi equals, alright, so I'm just plugging in to this formula. So we know now that's going to be 2 times. Now I need to find the sine of pi. Well, remember the sine is the y coordinate, which sine of pi is 0. So that would be 0 times 2 is 0. So these are my coordinates. The x coordinate is -2. The y coordinate is 0. Alright? Now, if we think about this, it's easy to kind of verify that that is the same point, because if you look at this, right, the radius is 2 and the angle is pi, which is 180 degrees. So if we go out to the circle of 2 and then 180 degrees, then it would obviously be to the left 2 and up 0, right? So they're actually plotting the same point. So we just kind of verify graphically in our head that the conversion was done correctly. All right. Another one. So let's say this time we're going to convert this polar coordinate to rectangular coordinate, -4 comma 2 pi over 3. Again, we'll start with the x. All right, and we will go the radius first, -4. Okay, once again, following this formula. All right, so that will be then cosine of the angle, which is 2 pi over 3. All right, so that's going to be -4 times. Okay, so let's see what the cosine of 2 pi over 3 is. So 2 pi over 3 is here. The cosine is the x coordinate, so that'd be -1/2. And so that goes here. And -4 times -1/2 is a +2. So 2 is the first coordinate. Let's do the y side of it now. So that's going to be -4 times the sine of 2 pi over 3. All right. So we'll have -4 times. Now we need to see what the sine of -2 pi over 3 is. So we'll go to the same angle, right? And we can see that the sine, the x coordinate, is square root of 3 over 2. And so that's going to be times square root of 3 over 2. So that'll leave me with a negative result. That 4 will divide by 2 and make 2, so that's -2 square roots of 3. So I have my rectangular coordinates now. It's going to be 2, -2 square roots of 3. Okay? All right, so that's a couple of examples of polar to rectangular. Let's do a few now of rectangular to polar. Rectangular to polar. So given this point, -1, -1, let's change that to polar coordinates. All right. So if we're going to go and change that over to polar coordinates, right, then the first coordinate is the r. Well, what's the relationship between the r's? Well, r squared is equal to x squared plus y squared, so we'll tackle that one first. So r squared is going to be equal to -1 squared plus 1 squared, right? And so that is going to be 1 plus 1, which is 2, and then I'll take the square root of both sides, which is going to be the square root of 2. So there's my radius, square root of 2. All right, let's see if we can find the angle now. What's the relationship of the angle? The angle is going to be the tangent of the angle is equal to y over x. So I'll write that as tangent of theta equals to y over x, which is 1 over -1. All right. Okay, so from here, then we know 1 over -1. We can go ahead and write that as -1. All right. So really, I'm looking for an angle, okay, whose tangent is -1. I'm looking for an angle whose tangent is -1. All right. Now we have to kind of be careful here, right? Because as I'm looking at this unit circle, and remember, okay, it's y over x, okay, so here I have square root of 2 over 2 over negative square root of 2 over 2, so that's negative 1 at 3 pi over 4, right? But it's also negative 1 at 7 pi over 4, because I would have negative square root of 2 over 2 divided by square root of 2 over 2, which is also negative 1. So there are two values on the unit circle for tangent that give me negative 1. So how do I know which one the angle is? Is it 3 pi over 4 or is it 7 pi over 4? Well, the way how you can tell which one to use, because remember, tangent has a period of pi instead of 2 pi, which means there's going to be two answers for every full rotation of the unit circle. So that is a good question. Which one are we going to use? Because either one could work, right? And it realistically, remember, in polar coordinates, you can go all the way around, so it could land on either side. So how are we going to, I'm saying it's possible that it could be either one of the values. And so how are we going to tell which one? Well, take a look at the original rectangular coordinate. It's at negative 1, 1. So what quadrant would that be in? That would be in the second quadrant, right? And so I know the answer that I'm going to pull is going to be the one from the second quadrant. So it's going to be 3 pi over 4, right? So my angle here is going to be 3 pi over 4. So now I can write my rectangular coordinate as square root of 2 comma 3 pi over 4, and that's the rectangular coordinate to the polar coordinate negative 1 comma 1. Alright, so again, since remember the period for tangent is pi instead of 2 pi, which means there's going to be two values that work when you go and try to figure out what angle. There'll be two angles that work typically when you go and try to figure this out. So which one are you going to use? You're going to use the one from the same quadrant that the original rectangular point is in, right? So in other words, you can't have a rectangular point over here in the second quadrant if your polar coordinate is over here in the fourth quadrant. They're not the same point, right? You've got to pick the one that's going to make the same point. All right, so that's how you tell which quadrant to choose your answer from when you're trying to find the angle, right, with tangent. Okay, let's try another one. So I want to convert this point now, 5 comma negative 5, to polar coordinates. Well, let's see. We'll start with the r. So r squared is going to be equal to 5 squared plus negative 5 squared. Okay, and so let's see here. So that would be 25 plus 25, which is 50, and we'll go ahead and take the square root of both sides. So we'll call that square root of 50. So there is my radius, but we can kind of simplify that down a little bit further because that's going to be equal to the square root of 5 times 2, which can actually become 5 square roots of 2. And I would say that's the best way to write the answer for the radius. All right. Now let's go with the angle now. So we know that the tangent from the formula, tangent of the angle is going to be equal to y over x, negative 5 over 5, right? And so that divides out to negative 1. So I am once again looking for an angle whose tangent is negative 1. And so let's see, we already know what values that would be at. That would be at either 3 pi over 4 or 7 pi over 4. Happen to be the same two values from the last problem. But let's take a look. Where is this now? 5, negative 5. Over 5 and down 5. That's in the third quadrant. So unlike the last one, we're not going to take 3 pi over 4. We're going to take 7 pi over 4 as our answer for the angle, because the quadrant needs to match up with the quadrant of the rectangular point if they're going to be the same point. Alright, so now we can go in and write our full answer for the new polar coordinate, which is 5 square roots of 2, comma 7 pi over 4. Alright, And there we go. We are done.